Hello friends, today I am going to explain you grade 9 science third lesson nature and properties of matter. In this lesson, matter can be classified into two groups as pure substances and non-pure substances or mixtures. Now we identify the pure substances and the mixtures separately. Firstly, we identify what are pure substances. Pure substances are the matter that contain only one constituent with specific features. Now we talk about the examples for pure substances. What are the examples for pure substances? Silver, aluminium, copper, distilled water, carbon, sulfur, zinc, copper sulfate and sodium chloride are those examples for pure substances. Now we identify what are mixtures or non-pure substances. Mixtures are matter that consist of two or more constituents which can be separated by physical methods. As examples for mixtures, we can got that drinking water, coffee, salt solution, fruit salad, seawater, muddy water, concrete mix. When we talk about the pure substances, we can divide those pure substances into two categories as elements and compounds. First, we identify elements. Elements are the pure substances with specific properties which cannot be further divided by either physical or chemical methods into substances with different properties. What are the examples for those elements? Iron, silver, chlorine, sulfur, zinc, copper, mercury and aluminium are those examples for elements. Now we identify what are compounds. Compounds are the pure substances with specific properties formed by chemical combination of two or more elements in a fixed ratio. As examples for compound, sodium chloride, copper sulfate and glucose can be given. Okay, now we identify some symbols of elements. Okay, first carbon. Carbon is denoted by capital C English letter. Okay, then oxygen is O, sulfur is S, chlorine is Cl, calcium is Ca, magnesium is Mg, aluminium denoted by Al, sodium is Na, copper is Cu, lead is Pb, gold denoted by Au, mercury denoted by Hg, iron denoted by Fe, silver denoted by Ag, hydrogen denoted by H, nitrogen denoted by N, zinc denoted by Zn, silicon is Si, phosphorus is P, argon is Ar, iodine is I and potassium is K. Then we are going to talk about the topic building units of elements. Under this topic, we firstly identify what are atoms. Atoms are the smallest particles can't be divided further that compose the matter which cannot be observed by naked eye or even by a powerful microscope. Now we identify the first scientist who introduced the atom to the world. John Dalton is the first scientist who introduced the atom to the world. Elements are formed with same type of atoms. As examples for this instance, we can get aluminium is formed with aluminium atoms, iron is formed with iron atoms, gold is formed with gold atoms. Okay, now we talk about molecules. Molecules are the units formed by the combination of one or more atoms of the same type or one or more types of atoms. Okay, those molecules can be categorized into two groups as heteroatomic molecules and homoatomic molecules. Firstly, we identify what are homoatomic molecules. Molecules that are formed by the atoms of the same elements are called as homoatomic molecules. As examples for homoatomic molecules can be given oxygen is O2, nitrogen N2, chlorine Cl2, hydrogen that is H2 and fluorine that is F2. Those are the examples for the homoatomic molecules. Okay, now we identify heteroatomic molecules. What are heteroatomic molecules? Molecules that contain atoms that are different from one another are those called as heteroatomic molecules. I have given you some examples for heteroatomic molecules. First one is water, that is denoted by H2O. Then methane, that is CH4. Then carbon dioxide, that is CO2. Ammonia, NH3. Hydrogen chloride, chlorine. CHL, HCl. Okay. Those heteroatomic molecules can be seen only in compounds, while the homoatomic molecules can be seen in only elements. Okay, now we talk about the atomic structure. At first, greater part of an atom is an empty space. The central core of an atom is positively charged and it is called nucleus. The nucleus was introduced by the Ernest Rutherford. The subatomic particles in an atom is neutrons, electrons, protons. Protons and neutrons are situated in the nucleus of the atom, and electrons are revolved around the nucleus. Since the electrons are very lighter than the protons and neutrons, Ernest Rutherford was introduced the planetary model, that is nucleus at the middle and then electrons are move around it as the solar system. Okay. Now we see some locations, founder, mass and the charge of each subatomic particles. We learn about subatomic particles later. Subatomic particles are the protons, neutrons and electrons. I have given you a table that shows the location, charge, mass relative to the electron and the founder of each subatomic particles. Firstly we discuss about proton. Location of proton is in the nucleus. The charge is positively charged and the mass relative to electron is 1. Founder of proton is Ernest Rutherford. Okay, then we're going to talk about neutrons. Neutrons is located in the nucleus. The charge is any charge. The mass relative to the electron is 1. The neutron is founded by the James Chadwick. Then we're going to talk about the electrons. Electrons are moved around the nucleus and the charge of electron is negatively charged and the mass relative to the electron is 1 over 1840. Electron is founded by the J.J. Thomson. Okay, now we identify the atomic number, that is denoted by S. Atomic number is the number of protons present in an atom. What is the symbol that denotes the atomic number? The symbol of atomic number is Z. Okay, I have given you 5 elements and their atomic numbers. First is carbon, that is denoted by C. Number of protons is 6 and the number of electrons is 6 and the atomic number also 6 because the number of protons is the atomic number. Then nitrogen, that is denoted by N, that number of protons are 7 and the number of electrons are 7 and the atomic number also 7. Then oxygen, that is O, number of protons is 8 and the number of electrons are also 8 and the atomic number also 8. Then fluorine, that is F, number of protons are 9, number of electrons also 9 and the atomic number also 9. Now we identify sodium, that is denoted by Na, number of protons are 11 and the number of electrons are 11, atomic number also 11. When we study in this table, we can identify that the number of protons in a nucleus and the number of electrons move around the nucleus are equal. Now we identify the mass number. The sum of protons and the neutrons present in the nucleus of an atom of element is mass number. What is the symbol that denotes the mass number? The symbol of mass number is A. I have given you the mass numbers of 3 elements. First one is nitrogen, that is N. Number of protons is 7 and the number of neutrons is 7. The mass number is equal to the proton plus neutrons, so the mass number of nitrogen is 14. The sodium, that is Na, number of protons is 11, number of neutrons is 12, so the mass number is 23. Then chlorine, that is Cl, number of protons are 17, number of neutrons are 18 and the mass number is 35. Okay, I have given you the standard method of representing atomic number and the mass number of an atom here. Above diagram shows the standard method of writing atomic number and the mass number of sodium element. Okay, this is the symbol of sodium element, that is Na. Above the sodium element, we can see the sum of protons and neutrons. What is that? That is mass number. And below the symbol we can see 11, that is number of protons, that is atomic number. Okay, this is the standard method of writing the atomic number and the mass number of an atom of an element. Okay, now we talk about the compounds. What are compounds? We discussed about compounds later. The heteroatomic molecules can be seen in these compounds. We can discuss about the heteroatomic molecules later. There are specific chemical symbols for compounds. Also, these symbols are known as chemical formula of compounds. Now we see chemical formulas and elements contained in some compounds. I have given you a table that shows those factors. First column is compound, second column is chemical formula, and the third column is any elements contained. First we identify the water. The chemical formula is H2O and the elements contained is H and O, that is hydrogen and oxygen. Then glucose. Chemical formula of glucose is C6, H12 and O6. The elements contain now C, H and O, that is carbon, hydrogen and oxygen. Then methane, that is CH4. The elements contained are C and H. Then acetic acid, that is denoted by the chemical formula of CH3COOH. The elements contain now C, H and O, that is carbon, hydrogen and oxygen. Then ethanol, that is C2H5OH. The chemical formula is that, and the elements contain now C, H and O. Then hexane, that is the chemical formula of hexane is C6H14. The elements contained are C and H. Then ethene, that is C2H4. The chemical elements contained in C and H, that is carbon and hydrogen. Then sodium chloride, that is the chemical formula is NaCl. The elements contain Na and Cl, that is sodium and chlorine. Then copper sulfate compound, that is the chemical formula of copper sulfate element is CuSO4. The elements contain Cu, S and O. Then calcium carbonate, that is denoted by C2CO3. The elements contain Ca, C and O. Now we identify mixtures. What are mixtures? Mixtures are formed when two or more pure substances get mixed. The pure substances in the mixtures are called constituents. I have given you the constituents of 5 mixtures here. Firstly, we identify the constituent in air. Air is the first mixture I have given here, and the constituents are nitrogen, oxygen, argon, water vapor and CO2, that is carbon dioxide. Then seawater, the constituents are water, salt, dissolved oxygen and dissolved CO2, that is dissolved carbon dioxide. Then I have here the third mixture, that is cake mixture. The constituents are sugar, flour, water, coloring, butter and eggs. Then the fourth mixture is crude oil, that is constituents are diesel, petrol, kerosene and tar. Then last and the fifth mixture is fruit salad. The constituents included in that mixture is banana, sugar, salt, pineapple, lime, apple. Okay, there are some physical methods that are used to separate mixtures here. First one is panning. That is separating sand from rice is panning. Second one is winnowing. Separating chaff from rice is winnowing. And the fractional distillation is separating various fuels from crude oil. Fourth one is stream distillation, that is separating cinnamon oil from cinnamon leaves. And the fifth one is crystallization, that is separating sugar from cane sugar syrup. Sixth one is sifting, that is separating gravel from sand. And last one is uses of magnets, that is separating minerals from mineral sands are called uses of. Okay, now we identify the categories of mixtures. Mixtures can be categorized into two groups. As what are these two groups? Homogeneous mixtures and heterogeneous mixtures. Firstly, identify what are homogeneous mixtures. The mixtures with the uniform composition right throughout the mixture is called as the homogeneous mixtures. As examples for mixtures, salt solution, sugar solution, sea water, and cake mixture can be there. Then we're going to talk about what are heterogeneous mixtures. The mixtures in which the composition is not uniform throughout the mixture are called heterogeneous mixtures. As examples for heterogeneous mixtures can be muddy water, mortar mixture, ice cream, and fruit salad. Okay, this is the end of my speech. Thank you for listening to me.